Welcome back, grade 7s. Here we are with the second part of our statistics unit this year. So last week we learned about the mean, the median, and the mode. We're going to do a quick review of that today as well. This week we're going to be learning about range and outliers, and then I have a project for you to do as well. So starting off, I've posted a data set on the board. This is a bunch of numbers. Let's suppose that in this case, this is an indicator of, I don't know, how many, no, I'm going to go for it. How many Pokemon cards a person has in their house. And so most of the recipients here, we got a 9 cards, 15 cards, 6 cards, 150 cards. Whew. 11 cards, 10 cards, 5 cards, 9 cards, okay? I am actually going to start off by calculating the mean, the median, and the mode for this data set before we even get into talking about range and outliers, because it's important to see how the outliers can affect a data set, okay? So let's start with the mean, okay? So as you should know by now, in order to calculate the mean, you have to add up these numbers. That's going to be fun. And then you have to divide by how many there are. So let me see here. That means we got 9 plus 15 plus 6 plus 150 plus 11 plus 10 plus 5 plus 9, and then another 9. I got to add all of these up. Okay. So let me see here. I got 3 9s here in a row. That's 27 plus another 10 is 37. Plus 7 more gives me 44. So I write the 4, and then I carry the tens position up over here, and then I've got 4 plus 1 plus 5 is 10. 11, 12. So I write the 2, I carry the 1, and I end up with 224 as my sum for this one. And then I've got to divide, right? So 224 divided by how many numbers are there? 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 numbers, good time. So 9 fits into 22 twice. And 9 times 2 is 18. 22 minus 18 is 4. 9 fits into 44. Oh, not 5 times, close. 4 times. Whew. 4 times 9 is 36. 44 minus 36. What a mess. We get 8 left over. 9 fits into 8. 8 times. That's 72. Oh, and we end up with a repeating decimal. So we end up with 24.8 as our mean. Okay. So our mean here is 24.8. Most of the time, we don't give you data sets that are this mean, right? Your assignment last week was pretty much all whole numbers. This is a more random data set, and it was a little bit harder work to do. Next, we're going to calculate the median. So that means I have to put my numbers in order. So let me see here. My smallest one is 5, then 6. And then I got 3 9s in a row, right? 1, 2, 3, a 10, an 11, 15, 150. Okay, so for our median, we find the middle number. Sort of cross out stuff on either side. So here we go. The 5 cancels the 150. The 6 cancels the 15. 9 cancels the 11. 9 cancels the 10. And there we are. Our middle number is 9. So our median is 9. And our mode, you should have picked out already by now because there's 3 9s. None of the other numbers repeat. So the mode is 9 as well. Okay. Now notice something really weird here. 2 of our measures of central tendency are exactly the same. And then we have one that's been dragged way off course. And we wonder, gee, why is that? Well, the answer is that inside of our number set, we had a number that was way bigger than all the other numbers. Okay. It's a number that doesn't quite look like it fits. It's really far off. Okay. And so in this particular case, that number is the 150, right? It is a huge number in a data set that is mostly made up of single digit numbers, right? Most of the numbers are pretty small. And then we have this 150, okay? So that is actually what we call an outlier, okay? So an outlier is a number that does not belong in a data set. It doesn't look right. It's very different. Oh, I'm handwriting again. Oops. Okay, so this is the number that's very, very different. So in this case, the 150, okay, makes our data set very, very different. It throws things off, okay? And so sometimes in math, we talk about, oh, there's an outlying value here. Should we remove it from the data set, okay? Sometimes the answer to that is yes. Sometimes the answer to that is no. You have to then investigate your data set and find out where that 150 came from. Okay, so in this case, maybe there actually is someone in the class who's a huge Pokemon fanatic and they have 150 cards. They just do. They're that interested. Well, if that's the case, maybe you should include that in your calculations. Okay. Chances are, though, if you want to predict how many cards the average student has, you're not going to use the mean in this case, right? Because there is an outlier. On the other hand, maybe you go back into your survey results and you discover that, oops, that person didn't have 150 cards. They had 15 and we accidentally added a 0, in which case, yeah, you would definitely remove that outlying value. You have to fix your numbers, okay? So it depends. Realistically, whether or not we remove an outlying value is dependent on circumstances. Your basic assignment today is not going to ask you that question. It's not going to ask, should we remove an outlier? At least I don't think it does. Let me double check. Yeah, it doesn't ask that. It just asks you to calculate, okay, just to see if there is an outlying value. The challenging assignment, however, is all about this. It's about the real life application of statistics. And so it will have questions like that. Hey, is there an outlying value? Do you think we should pull it out of the set? Why or why not? Okay. The other term here that's new, the range. Okay. Range measures the spread of a data set. In other words, it measures the difference between the highest number in the data set and the lowest number in the data set. Okay. It measures the spread of the data. Okay, measures the spread of the data. And in order to calculate the range, you take the highest number in the data set and you subtract the lowest number in the data set. So in this case, that would be 150 minus, what's our lowest one? 5? 5. Okay. So our range here is 145. So when you have a range of 145, but you have a median of only 9, yeah, you got yourself an outlying number, okay? You got an outlying value. A range is an indicator of how likely it is that you have an outlying value when you compare it with other measures of central tendency, okay? Now let's go back to our hypothetical data set over here. Suppose that we pulled out that 150, we got rid of it. This is going to change some of our measures of central tendency, but not all of them, okay? So say, for example, our mode here. Is this going to change our mode? Not at all, right? There's still 3 9s. The mode is going to stay the same. Is it going to change the median if we get rid of this? The median is going to be shifted this way. Actually, it's not. The median stays 9 as well. So this is something you'll find when you remove an outlying value. The median and the mode tend to be very consistent. They are not likely to change. The measure of central tendency that does get dragged around is the mean, okay? So if we were to pull this 150 out, instead of the sum being 224, we would then have a sum of 74, okay? It's 150 less, right? So our sum here would be 74, and we would divide that by 8 instead of 9. Here we go. 74 divided by 8 is 9, and we have 2 left over. 9.2, and we have 4 left over. 5. 9.25 is what this would end up being. And the really interesting thing about that is that if your mean is now 9.25, okay, now it's really close to your median and your mode. Okay, so that's the other clue that you have an outlying value. If your mean is really, really different from your median and your mode, maybe there's a number that's much bigger or much smaller than other numbers. Why is this important? Well, Statistics can actually be used to manipulate and lie to people, okay? If a company has an outlying value in a survey that they've done and they choose to include it in the data set, even though they made some sort of mistake, they can throw their results off, right? The same is true for governments and all kinds of things. They can use statistics and manipulate them to deceive as well as to inform. And so it is important for you as an informed, responsible citizen to be able to understand statistics and know when someone is analyzing a data set and they're manipulating numbers in weird ways, and they start calculating the mean, but their data set has this weird outlying value. We want you to be smart enough to be able to pick up on that and say, no, you're trying to pull the wool over my eyes. That's not cool. Okay. This is not something, of course, that you're going to do in grade 7. It's something you do as an adult. You will continue learning statistics and working on them throughout high school. So don't stress over figuring out how to do that right now. Okay. Your other assignment this week, there's no quiz this week because range and outlier are dead easy. So one assignment ought to do it. Instead, what we are doing, what I am asking you to do, this is not the right bundle of assignments. What I'm asking you to do is to do a survey, okay? So you are going to do your own statistical survey on the pets of your classmates and staff members and community members and relatives and whoever else you want to talk about. So I'm asking you to contact at least 10 people, okay? Your choice, preferably from different households. You are going to ask them how many pets they have, and you're going to record the information in this lovely chart here, okay? You can do more than 10 if you want to. I know I have certainly enjoyed seeing your pets since this online schooling thing started. I've had the privilege of seeing quite a few students' pets. So if you want to contact and you want to ask about pets, it's kind of fun. So you're going to take down this information, and then we're going to do some math calculations with it. We'll find the mode, the mean, the median. We'll find the range. We'll see if there's any outlying values. Is there someone in the class who has like 300 pets for some reason? Who knows? It's possible. Have fun with it. Okay, guys? So that's the rest of the work for this week. I hope you enjoy it. Have a good day.